Hi, everybody. Thank you for joining us again for the third session of the Encode Polkadot Educate series. We're really excited to see you all here again. Today we have a talk from Aurora Poppyseed, aka Poppyseed Dev, the founder of Lastic. I'm just inviting her up to the stage. We're really excited to have her here today. Hi.
Hey.
Hey, I can hear you perfectly. Awesome. Okay, as always, put all your questions in the chat. We'll get to them at the end.
My name is Aurora Poppyseed. I'm a technical founder at Lastic and a full stack developer and BBA graduate. And of course, I like course and chess and coding, of course. If you want to connect with me, here's my basically my Telegram, my Twitter. And if you, oh, sorry. Okay. Cool. So, how familiar are you guys with Polkadot? If you can write in the chat quite quickly, like 0 is zero familiarity, 5 is a lot of familiarity. Okay, PBA Hong Kong, 4 in the house. Okay, I don't know what are you doing here. Good, 4, nice. Cool. Okay, we have a lot of familiarity, nice. Okay, then we are gonna go really quickly through the very easy stuff. Nice. Okay. Wow. So many fours. Nice. Okay. We're gonna still do a little refresher of how blockchains work, though. But we're very quickly, right? So how does a blockchain work? We have a bunch of nodes in the blockchain, and all these are different computers that are connected to the blockchain, and they're producing a chain of blocks and adding transactions to them. Here we should distinguish between two concepts. So one is the nodes. I have my notes here because I always forget. So one are nodes, which are responsible to store transaction history and maintain a copy of the blockchain. And another is validators. So there are different types of nodes which basically actively participate in the consensus mechanism of the blockchain. And if you are all PBA graduates here, so what is the consensus mechanism of the Polkadot? So grandpa. Yeah, grandpa. Yeah, amazing. Grandpa with beta, I believe. Okay, great. So we have a bunch of, basically we are producing blocks over time. And if we tamper with the history somewhere here, then all the blocks are incorrect in the future. Great. So what are cores in this context? What are even cores in the context of blockchain? Well, we have a core and we have knowledge of a single computer. So in the simple computer, we have multiple cores, right? We can check in the Mac. We go to hardware settings. We can see this is an old Mac. Their total number of cores, 4. Okay. So cores basically allow us to process multiple things at once. So we can basically do parallel processing. For this simple overview in the computer, we have one core controlling the mouse, another core controlling the keyboard, and we have again here, I don't know if you are familiar with Sims, two cores are controlling basically our game of Sims. Anyways, this is very simple for now. We get that. But what is a core in the blockchain context? Okay, so we have, yeah, I know Sims is amazing. So when we have multiple validators in the network, what is a core in this context? Or when we have 300 nodes, what do we mean here, right? But let's go a few steps back. before we understand what is a core in this context. We first have to kind of get an overview of sharding. So sharding basically originates from the field of database management and distributed systems. So I don't know how familiar you are with classical databases, but in the context of the database, you have basically a small database here, or let's say a big giant database here, and we are we're just inputting Andra, from Petersburg, Angelica from Washington, Anna from Ohio, Tim from Tennessee, and so on. And if you can imagine, all these people are trying to interact with this database. And also our Bob over here is trying to interact. And he's very annoyed because the latency is so huge. So what did developers decide to do? They decided to basically shard the database and have multiple, like split it up into 3 separate databases, and each one having in the most simple setting, we say database 1, you will handle all names from A to M. Database 2, you will handle all entries from O, N to P. Okay, and the third one, will handle all database entries from R to Z. Z is the last letter? In Slovenian. So Bob has now no latency problems and is quite happy in this and can interact with the database without any problems. Okay, but what is happening with blockchains in the context? So what is happening with sharding in the context of blockchains? So we have a bunch of validators now again, and we can basically imagine it very simple to the context of normal databases. Basically, we have transactions going through, and now we're basically trying to split it into 3 separate transaction flows. So we have one huge. So before we had only one blockchain that was accepting. So we had a single blockchain which was accepting all transactions, and they were queued. And now we basically split it up into multiple different shards. So this kind of look like this, right? It's a very simplified overview, but basically it's split into multiple. So the blockchain splits into multiple shards, each one functioning as a mini blockchain in a sense. It's basically each shard processes their own transactions and executes. It's responsible for executing its own transactions and smart contracts and so on. So, and in the context of blockchain, we then say, okay, this is one core, this is another core, this is another core, and basically we have parallel processing in that way. It's a very simplified overview, but I think it's enough for you to get an idea of how this works. So, and how this works in the context of basically Polkadot. So we have a bunch of validators, collators, and so on. You're all familiar with the architecture, but basically we have each individual core allocated to a certain parachain. All right? Okay. I think that's quite explanatory. Any questions at this point, actually? No? Yes? So far, so good. Okay, amazing. Okay, what is Coretime? So, sometime with this guy, or maybe you can have ads like this guy. Well, not exactly. It's basically the time you have with a core. Not with that guy, unfortunately, although we would all want that. It's yeah. So basically, you have a computation on a core, and basically, core time is allocated in the Polkadot 2.0 for 1 month duration. Okay, and how can I get some core time? So how can I get some core time? Well, let's first understand the history first. So our system before were English options, and you basically got core over the duration of 2 years, right? So a lot of people were bidding, and an English auction, you're all familiar in the PPA, was the concept was taught quite well. You basically start from a low price, and then Mar bids, I don't know, 10 euros, 10 dot, then Alice bids 12 dot, then Bob um, then says, I want to buy this core for 14 dot and so on, right? So we get over time, we get a higher and higher price. Amazing. So, and then with the candle auctions, which is introduced in the Polkadot, we say, okay, you guys are bidding, and then at random time we say, stop, this is sold. Okay. So if we check, kind of, this were one of the first auctions in the history. So we had bidding. Here a color one with the candle auction. Then the bidding continued, Moonbeam won, and so on and so on. And people were actually contributing the funds, and you got basically there was a concept called crowd loans, which is still actually now present in the Polkadot. This would be replaced, but basically people got their dot locked for a period of 2 years, and then they could not use it anymore, but they would basically say, look, we lock it for Moonbeam, we support Moonbeam for this, and please Moonbeam give us some of your glimmer, I believe it is. So if you can see in the first kind of crowd loans, these prices went huge, right? It was 200,000 euros. That's dollars. That's crazy. So what is the system now? The system now we have basically is Dutch auctions. So you have basically a core allocated for a month, and then you can once you buy it, you can renew it for a certain parachain, and then you have it the next month, and you have to renew it basically each month. And we'll have soon auto renewal, so this won't be such a problem. And then, so if you buy it at the price of 10 dot, then next month you will buy it, and you can renew it at 10.5 dot, and so on. So it goes up by, I believe, 5%, something like that. The still undetermined for Polkadot what it will be. So system now is basically Dutch options, and the price goes down, as we said. So we have basically the auctioneer, and we're selling 5 cores over in this time duration. And let's look at how this looks like. So the price is huge at first. First guy buys the core, gets it. Second guy buys the core, gets it. Third guy gets the core. Fourth guy gets the core. So you're basically trying to buy it in the lowest prices possible, and you're buying it again. But these guys who bought it later on, when all the cores been basically already given out, they cannot reach it anymore. So what is your best bet in this kind of auction? Your best bet is waiting as much as possible. So your best bet is to be like once the first bid comes in, your best bet is to be like the second bidder or the third bidder. So you basically don't want, you never want to be the first bidder, but want to be like second, third, fourth, fifth. If you're if you go for the first, if you go to the second, the last, or the last, it's maybe not a good strategy because somebody can always beat you to it, right? So it's always good to wait for the first bidder and then maybe go right after him or wait for the depending on how many cores there are, you want to be somewhere in the middle. But it's very funny because when you get the first bidder, if it's very competitive, it goes first, second, third. So that's kind of the idea. So yeah, this is kind of the pricing now. So we have 100x from the price where it settles, and then this is 100x, and then this is kind of 10x, and then it settles down at the normal price. So how can I get some core time? So you go to Lastic, click launch, buy a core, very simple. You wait for the period to be correct. So we have this linear decreasing time, and then we have the stable price, and this is the renewal period. So in the renewal period, of course, you cannot buy the core, and then you're basically waiting for the price to decrease. You click buy the core, you wait for the basically the price to be correct, and then once you obtain the core, you can see it, or I have a better overview on it. And now what we can do is do a bunch of things with it. One of the things we want to do, of course, is if we have a parachain, we want to assign it, right? So how do we make our core work? So first we have to create a par ID, and we have to then register it. So first we have to reserve a par ID. So we have to reserve a par ID. For this, it's quite a huge deposit now. And then also there is another deposit for registering your parachain. So here you provide your WASM blob and your Genesis hash, and you wait for a certain duration of time for this to get basically approved. And once you get it approved, you then can assign the core when you obtain. So we have to, what do we have to do? We have to buy the core, reserve it, buy the core, create a new par ID, register your parachain, and then basically assign it. So you can assign it to a certain par ID, and that's it. And now you're good to go. So let's go a bit more into details now. What else we can do to the core? We can transfer it, great. We can split it, and we can change the frequency of it. Let's check in that, and let's also go into the concept of Lastic Scaling, which I don't believe it actually works yet. As of now, it doesn't work, I believe. But in a sense, in the future, you will basically be able to buy multiple cores and assign it to the same par ID, so the same parachain. How do we call it nowadays? I think parachain. I'm still calling it parachain. Yeah, so basically you will be able to buy, I don't know, 5 cores and assign them all to the same par ID, and they will actually work in this way. This currently, I don't believe it works yet. What it will be able you to do now, you get, so we have 12 blocks. So every 12 blocks, every 12 seconds there is a new block. What it will allow, it will be the procurement of new blocks would be, I think, every 6 seconds or something like that. So basically, if you would have multiple cores working together, you can get much faster transactions throughput, which is amazing, right? If you think about it. What else can we do with our cores? So we can split them up. So maybe the terminology I'm using all these times, I'm using a simplified terminology of cores. This is not exactly correct. It should be regions. So a region is basically a core in time. It's core time. A region is core time. A region is basically the core allocated to you in a certain amount of time. So once you get a region, you can split it up into 2 weeks. So first, or however you want it, you can say, hey Bob, your friend, you will take my region for the first 2 weeks, and I will take the region for the next 2 weeks. And do, I don't know, like I just need computation resources for 2 weeks. If you want, you can use it for the other 2 weeks, or a week, or you can split it out however you want. But better concept that I like is interlacing. And basically interlacing is, so I know this is not the best picture, but basically what happens, you have a bunch of time slices. So you have tons of little time slices. Maybe this is a better picture or not. So you can basically adjust the core frequency. So all these, what you can do, all these black boxes, all these black parts are basically can be assigned to Bob, and all these white ones can be assigned to Alice. So then how it would work, basically both of us share the same core, but it would be like this. I would use it for 12 seconds, then Bob would use it for 12 seconds. I would use it for 12 seconds, then Bob would use it for 12 seconds. It would be basically kind of interchangeable, right? So this is what interlacing actually means. So yeah, if you go to, if you buy a core, you can also change the frequency for your core and then basically share it with somebody else. The problem with this, unfortunately, is that once you do any kind of splitting or changing of the frequency, you cannot renew your core. Unfortunately, maybe we will change that in the future, but for now it is how it is. The proposal was for it to not be able to, for people not to be able to have changed the frequency and then to renew the core, because only for the fact that I mean, Gav was kind of concerned that people would be misusing this renewal process, because the economics are in favor of you when you are actually renewing the core. So actually, I can answer some questions here. What happens when I want 5 cores of my data-intensive backward parachain? Do I need 5 separate blockchains? So no, you don't need 5 separate blockchains. With Lastic Scaling, it would enable you to use one blockchain. And you could use 5 cores in this context. Are all the cores the same processing power if they have the same computation power? Yes. Is this splitting one task between multiple cores or one core between multiple people? So splitting is splitting up one core. So splitting up, basically, you're not splitting up a core, you're splitting up a region. So duration, time when you have on the core into basically, you have, when you buy a core, you have time with this core for 1 month. And what splitting basically means is I gave a week to Alice, a week to Bob with this core and 2 weeks to somebody else. What happens to my chain state if I miss an auction? If you miss auction, it goes away. So basically, you will still have a par ID assigned to you, and it will be registered, but there won't be any execution on it. So once you register a parachain, your parachain is registered, and everyone knows this parachain belongs to this head, this Genesis head, is basically things like that. But if you don't have a core allocated to this registered parachain, there won't be any executing. Is this splitting one task between multiple cores or one core between multiple people? You have a core. So currently, like, think of it first like this. You have a core, you have a parity, you allocate one core to a parity. And then for other scenarios, you're basically, for this scenario or for this scenario, you are splitting the core. Well, you're not splitting the core, you're splitting the duration in time. You're never splitting a core. You're just basically, first I'm using it, then you are using it, then I'm using it, then you're using it. If I don't use all the power of a core, can I share it with another project? Yes, if you interlace. Although the problem is currently, if you interlace it, you have the problem that you won't be able to renew it. So it's economically less beneficial for you. I understand splitting the time with the core, not the actual core. Yes, yes. So, what is our vision of the future? Stop making more chains, make existing chains hybrid. That's our vision for Polkadot. Currently, it's unfortunately, with Ethereum, it's super easy to develop. You just have tons of smart contracts, you deploy a smart contract, and that's it. And kind of, I hope the vision for Polkadot could be in the future that you would have specific functionality for that chain would facilitate. And then on each one of the chains, you could have additional smart contracts. This is coming now with Plaza, and I have a proposal out for adding smart contract functionality to Coretime chain, which hopefully it has. Looks like it's quite good sentiment on it. Basically, we need faster development cycles in the Polkadot ecosystem, and I want every chain to handle smart contract functionality plus its own chain-specific functionality. So we can have like super specific functionality that's super fast, and then smart contract functionality on top that allows for faster development cycles. And Rob was talking about hybrid chains a long time ago, and I believe now is finally the time where things are starting to happen. So this is the context of Lastic. If you want to get a core, or if you want to connect with us, check out our Twitter. This is our website. And we are doing a core gem implementation with Python. And if you want to join us, if you want to join our team, DM me Poppyseed Dev on Telegram. We believe that we can get basically white Python. Python is super, super fast to develop with, and we want to be one of the first implementers of core gem. And we believe we can do it. And basically, our goal is to implement it and then open source the code for easier implementation of core gem for anybody else in the future. That's the idea. If you want to join our team, we're still looking for people to join, and yeah, let's go.
But Ken was basically saying, other than the traditional buying option, where you can get renewal, is there another way that you can sort of make sure you don't lose your core time in the future because you don't renew it? So he's talking about missing auctions, so you miss your renewal. Or I think you said that with some buying options, like if you split up I've forgotten the term, when you share it out,
Yeah.
you can't renew your core. I think that's what he's talking about.
So if you will basically, I'm just gonna mute. So if you basically change the frequency or basically split the core, you will lose the ability uh, to actually renew it. But it's an interesting experimentation thing if you want to try it, and I hope in the future we will have also renewals available for the frequency and splitting up the core. That would be amazing. Now I think best to just basically assign it, and that's it. In the future we will also have like core time sales, so people can buy it and then sell it later. With renewals, you have to make sure that you basically renew it for at a specific time period. We're still working on the documentation on that to have it more clear, or maybe have the UI a bit clearer on that point. So you will exactly know. And another thing that we're working on is basically that is coming soon is auto renewal. So basically, be able to renew and renew in the future, in the future. So it will renew for yourself, and you, if you miss the renewal, it will also renew for you. So that's amazing.
So I hope everyone enjoyed that session. I found it really informative, especially the explanations about I've already forgotten what they're called now, but the splitting and the when you share between people, when you alternate their access. Really interesting. So thank you so much, Aurora, for coming on. A lot of thank yous. Awesome. Okay, so unless anyone else has any more questions, we'll end the session here for today. Nope, just lots of thanks in the chat. Cool. Awesome. Thank you guys for joining us again. And we will see you on Thursday. Bye, everyone.